In this lecture, we're going to discuss the third method of preparing salts, and this method is called ionic precipitation or simply precipitation, and it's a method that is frequently used to prepare insoluble salts. So any salts that are insoluble would be prepared using this particular method, which is called ionic precipitation. It's a very the description of this method is very easy, and the way it is done is that you take two soluble reactants. Now you're going to take two soluble reactants, and those two soluble reactants must react and to produce an insoluble salt. So the product would be an insoluble salt from two soluble reactants. Now the thing with these reactants is that they may or may not react together. It's not important that they react together, and I'm going to do develop an understanding for this by giving you examples. So they may or may not react together. And it would be this would be another equation in acid base and salts that we will discuss just after a few moments. So we're going to take two soluble reactants which may or may not react together, but they must be soluble, and they're going to produce an insoluble salt. So how is that done? So I'm going to describe the first case, which is, let's think of two soluble reactants which react together. For example, I have barium hydroxide. So that's BaOH2, and barium hydroxide is soluble. It's an aqueous substance. It's very soluble. Hydroxides have high solubility down group 2, so barium is at the bottom of group 2. So group 2 hydroxides that are at the bottom are very soluble. So barium hydroxide is soluble, and I'm going to react it with phosphoric acid, H3PO4, which is also a very soluble substance. It's an acid. All acids are soluble. So it's barium hydroxide, which is a base, reacting with an acid. And when a base and an acid react, they're going to produce salt and water. So the salt that's going to be produced is going to be barium phosphate. Plus there's going to be a water molecule produced, and you can balance this equation. This barium phosphate is insoluble, so it's going to be in solid state. It's going to be a precipitate. So precipitate is the solid that is formed when two substances react. It's an insoluble solid. H2O is a liquid, and so this one is a salt, and you have a water molecule produced. So it's a typical acid-base reaction, and we can balance this equation as well. There would be 3 barium hydroxides, and there would be 2 phosphoric acids, and there would be 6 water molecules. So that's your balanced equation. So how are you going to perform this reaction in your college laboratory? So what you're going to do in the college laboratory is you're going to first take a beaker. And remember, I told you that the method of preparation is very easy. So you're going to take a beaker, and you're going to add the two reactants. So what you're going to do is you're going to simply mix phosphoric acid, which is H3PO4, and which is an aqueous state, and you're going to mix barium hydroxide, which also happens to be in aqueous state. So you're going to mix the two together. And once you mix them, so they're going to start reacting. So once they start reacting, they're going to start forming a solid precipitate, which is going to be barium phosphate, Ba3 PO4 2. So it's going to be a solid precipitate formed. And what you can do is you can easily filter this off. So this solid precipitate is simply filtered off, and you get your product, which is this insoluble salt. You can simply filter it off. So you can add any quantity of barium hydroxide or any quantity of phosphoric acid. You have no worries about adding excess barium hydroxide or excess phosphoric acid, because it's extremely easy to remove the product that is formed. You can simply filter it out. So even if you add excess phosphoric acid or even if you add excess barium hydroxide, that excess barium hydroxide or phosphoric acid is not going to mix with the solid precipitate, because that solid precipitate would be easily removed. So this is the easiest method, and the way you're going to describe this method when you're writing this down is that the first step is you're going to mix H3PO4 aqueous with barium hydroxide, which also happens to be in aqueous state. The second step would be that you're going to filter off the precipitate formed. So filter off Ba3PO4 to precipitate formed. And once you have filtered that off, the third step is, and you must note this down, this is very important, you wash the residue. So wash the residue with distilled water, and dry between pieces of filter paper, which are like tissue paper, so they're very easy to. As the reason why you wash the residue with distilled water in this case is because the residue is insoluble, so it's not going to dissolve in that water. So the phosphoric acid or barium hydroxide, that's still the solution that is still surrounding that solid precipitate, would get washed away without dissolving the barium phosphate. So whenever you have an insoluble salt, you're always going to wash it with distilled water. So wash it with distilled water and dry between pieces of filter paper, or put it in an oven, or put it in sunlight, so to dry the precipitate. So this is a very simple description of preparing a salt, an insoluble salt, using ionic precipitation. Now the second case that I'm going to discuss in the next lecture is of preparing an insoluble salt from two soluble reactants which do not react. We will now discuss the second case of ionic precipitation, and this ionic precipitation is going to take place when you mix, whenever you're going to mix two soluble, they must be soluble reactants. So whenever you mix two soluble acids, bases, or salts. So whenever you're going to mix two soluble acid, bases, and salt, and this case specifically is going to apply to cases where they do not react together. So you're going to mix any two soluble acids, bases, or salts which don't react together. Because if a reaction takes place, then you're going to follow the ionic precipitation that we discussed in the previous case. But whenever you're going to mix two soluble acids, bases, or salts, there is going to be a chance for ionic precipitation. So what's going to happen is that you might end up getting an insoluble product. And remember, you might end up getting an insoluble product. It's not always going to happen. You're always going to be on the lookout for an insoluble product. So what's going to happen is, I'm going to give you an example. what's going to happen is if you mix, if you have a beaker, let's have this beaker, and so I have this beaker over here, and what I'm going to do is I'm going to mix any two soluble acids, bases or salts which are not going to react together. For example, I'm going to mix HCl. Now HCl is an aqueous acid, and I'm going to mix it with silver nitrate, let's say. And silver nitrates, all nitrates are soluble, so that is also in aqueous state. So what I'm doing over here is I'm mixing an acid. So this here is an acid, and I'm mixing it with a salt. Now you already know that acids and salts, they do not react together, so there's not going to be any reaction between the two. So they're not going to react together. But what's going to happen is, and what will happen is, that since HCl is in aqueous state, and we know that when something is in aqueous state, it breaks up, it ionizes into its ions. So the solution that's going to be formed in this beaker is, it's going to contain a lot of H+1 and Cl-1 ions. So lots and lots of H+1 and Cl-1 ions would be present in the solution. The other thing that would happen is, since silver nitrate is also aqueous, so silver nitrate is also going to ionize. It's going to break up into silver ions and nitrate ions. So you have this solution, and it has all these ions simply roaming around, floating around in this aqueous state, in water, dissolved in water. They're just roaming around, and they're going to randomly combine with each other. Remember, positive ions are going to attract negative ions. So a positive ion would combine with a negative ion. So what's going to happen is that you might get H+1 might react with NO3-1. They're going to collide, and they can form HNO3. So the list of possible products that you're going to have. So let's say these are my possible products. So my first possible product that can be produced is HNO3. So H+1 ions might end up colliding with the nitrate ions, and they can get together, they can form HNO3. But remember, HNO3 that is formed is a very soluble acid, so it would be in aqueous state, it would dissolve quickly, and since it will dissolve quickly, it's going to break up again and form H+1 and NO3-1 ions back again. So this was in aqueous state, and since nitric acid is also very soluble, so it's going to break up into ions again. So you're not going to get a lot of nitric acid, because all the nitric acid is going to redissolve. It's going to break up into H+1 and NO3-1 ions back again. But on the other hand, what happens if Ag and Cl ions, they combine together? So if they're randomly colliding with each other, so you might get a positive ion of Ag+1, which is in aqueous state, and it might end up reacting with Cl-1 ions, which is also in aqueous state. And they're going to combine together, and they're going to form AgCl. Now AgCl is very insoluble. So this AgCl, when it forms, it's going to be an insoluble solid. This reaction would not be possible. It's not going to redissolve. So since it's not going to redissolve, it's not going to ionize. So what's going to happen is that in the solution, Ag plus ions, they will be used up, and Cl-1 ions will be used up, and Ag plus and Cl-1 ions would start reacting with each other, and they would start forming a precipitate of AgCl solid. So that is what's going to happen, that you're going to start getting a precipitate of AgCl solid. And whereas any nitric acid that is formed, it's going to redissolve because it's aqueous, it's going to break up into ions again, it's going to remain part of the solution. So you're going to get two products. And if I write an equation for this, my equation would look something like this. Okay, you're going to have, we had HCl aqueous, so we had HCl in aqueous state, and it was reacting with silver nitrate, which was also in aqueous state. And when I mix them together, the ions randomly combine with each other because they're ionized in aqueous state. And when they combine together, AgCl is not going to redissolve because it's an insoluble solid. So AgCl solid forms a precipitate, and the other substance that's remaining in the solution is H plus 1 and NO3 minus 1 ions. It's this thing over here in aqueous state. It's going to ionize back again, so I'll have HNO3 forming, but that would redissolve, so it's going to remain part of the solution. So I can then extract my insoluble solid by simply filtering out the solid. So what I'm going to write when I describe this reaction is, that the first thing I'm going to write is I'm going to mix HNO3, mix HCl, which is in aqueous state, and AgNO3, which is also in aqueous state. So I'm going to mix them together. The second part would be that I will filter out any precipitate that is formed, and in this particular case the precipitate is of AgCl. So I'm going to filter out the precipitate formed, which in this particular case is AgCl solid. And once I've filtered it out, so since it's an insoluble precipitate, I'm going to wash it with distilled water. So you wash the residue with distilled water. And the last step would be you have to dry them. So you wash the residue with distilled water and wash and dry between pieces of filter paper. So that is your second case of ionic precipitation. In that case, I'm going to revise this and go through this once again. You're going to mix any two acids, bases, or salts, and remember, this reaction might happen, or it may not happen. So I'm mixing HCl and silver nitrate, and both of them are aqueous. They don't have a conventional acid-base reaction because acids don't react with salts. So they're both going to be, since they're both aqueous, they're both going to dissolve in the solution, and they're going to form H plus 1 and Cl minus 1 ions formed by HCl, and Ag plus and NO3 minus 1 ions formed by silver nitrate aqueous, and they're going to randomly combine with each other, positive ions colliding with negative ions and combining. So if H plus 1 and NO3 minus 1 ions combine, they're going to form nitric acid, which is soluble. So it's going to redissolve and become part of the solution. But if Ag plus and Cl minus 1 ions combine, they form an insoluble substance, which is AgCl solid. And this AgCl solid can then be filtered out, and the precipitate can be washed with distilled water since it's insoluble, and you can dry the precipitate. And this method will only work if one of your products formed is insoluble. In this example, we're going to try and prepare lead to carbonate using ionic precipitation. So it's an example of ionic precipitation, which would be used when your salt or your product is insoluble. So lead carbonate is insoluble. So we're going to come up with two reactants. We want to make lead carbonate. So we have PbCO3, and PbCO3 is insoluble. Now to prepare PbCO3, we would need two reactants. One would contain lead ions, so it should be something that contains lead ions, and it should be soluble. So ionic precipitation only works if the reactants are soluble. So let's take lead nitrate, because we know that all nitrates are soluble. So we're going to take lead nitrate, and we're going to react. So this particular substance contains lead ions, and we need another substance which contains carbonate ion, which needs to be soluble. So let's take let's take sodium carbonate. So we have Na2CO3, that is sodium carbonate. So the first thing is that this particular uh, reactant contains lead ions, and this particular reactant contains carbonate ion. These are my two ingredients that are going to make lead carbonate. So we wanted to make this lead carbonate ionic lattice, so which is insoluble. So the way you're going to do this is you're going to take let's take a beaker. You're going to take a beaker and you're going to place these two aqueous solutions in that mixture, in that beaker. You're going to mix them in that beaker. So one is sodium carbonate. So you're going to put sodium carbonate into that mixture, sodium carbonate, which is aqueous, because all group 1 compounds are soluble. You should revise your solubility table to figure out which substances are soluble and which are sparingly soluble or insoluble. And the other thing that we're going to add is lead nitrate, which is also in aqueous state. So we have lead nitrate, lead 2 nitrate to be specific, and it is also in aqueous state. Now you'll have 4 ions in the solution. These two are salts, so salts, they don't react together. Lead nitrate is not going to have a reaction with sodium carbonate. What's going to happen is that when they are dissolved in solution, they're going to ionize. So sodium carbonate breaks up into it contains 2 ions, sodium ions and CO3 2 minus ions. So you'll have plenty of sodium ions and carbonate ions. And lead nitrate also, because it's soluble, it's going to break up into lead 2 plus ions and NO3 1 minus ions. And these ions are randomly moving around in the solution, and any positive and negative ions, they're going to randomly combine together. So they're going to randomly combine together. Now if Na and NO3 they combine, nothing much is going to happen, because when sodium ions and nitrate ions, which are both in aqueous state, so they're both in aqueous state, so when they combine together and they form sodium nitrate, which is also aqueous, so when they combine together, because sodium nitrate is soluble, it's going to break up and ionize again, so it's going to remain part of the solution. So sodium nitrate would not be obtained, it would remain part of the solution, and it would remain in its ionized form, which is sodium ions and nitrate ions. But on the other hand, what happens when lead 2 plus ions and CO3 2 minus ions combine, they react together to form PbCO3. Now PbCO3 is solid, and these ions were aqueous. So what happens is that PbCO3 is insoluble, so these lead ions and these carbonate ions, they start combining, they start forming a solid precipitate, which is going to settle at the bottom. So PbCO3, which is a solid, is going to eventually settle at the bottom. So, and you're going to get lead carbonate, which is solid. And the other other product that you're going to get, which is going to remain part of the solution, is sodium nitrate, which would remain part of the solution. So it would remain sodium nitrate aqueous. It would be in its ionized form. It's going to remain part of the solution. The way you're going to obtain lead carbonate solid is you're going to filter it out. So what you're going to write in your exam when you write this down is that you're going to tell which two reactants you're going to mix. In this particular case, you're going to mix lead nitrate aqueous and sodium carbonate aqueous, and you're going to filter out the precipitate which would be formed, which would be lead carbonate. So filter out the precipitate. Precipitate means the solid that is formed. So you're going to filter out the precipitate of PbCO3 formed, and once that precipitate is filtered out, because it's an insoluble precipitate, you're going to wash the residue with distilled water, or wash the precipitate with distilled water. With distilled water and and dry between pieces of filter paper. Between pieces of filter paper. So that's one way of forming lead carbonate solid. So whenever you have an insoluble solid, I'm going to revise the steps that we did. So whenever you have an insoluble solid, which in this particular case is lead carbonate, so lead carbonate would be obtained by mixing together two soluble substances. One contains lead ions and the other one should contain carbonate ions. And if you mix them together, basically what's going to happen is that lead ions from this substance are going to react with carbonate ions from the other substance, and they're going to form an insoluble solid. Because it's insoluble, it's going to remain settled, it's going to form a precipitate at the bottom which can be filtered out. The other ions, which were nitrate ions and sodium ions, they're going to combine, but they're going to remain part of the solution because sodium nitrate is very, very soluble. So it dissolves back into the solution as soon as it is formed, but lead carbonate can be filtered out. So that's how ionic precipitation would be used to form lead carbonate solid. In this video lecture, we're going to try and prepare calcium phosphate, and calcium phosphate is an insoluble salt. Now, insoluble salt, again, the method that would be used to prepare an insoluble salt is going to be ionic precipitation. So you'll have, you want to prepare calcium phosphate, and the way calcium phosphate, which is an insoluble salt, it's not going to dissolve in water, it's going to be prepared is that you're going to take two soluble substances. One is going to contain calcium ions and the other one is going to contain, it's going to contain phosphate ions, PO4, 3 minus ions. So they must be soluble. So what I'm going to do is I'm going to take let's say I'm going to take a soluble substance. Calcium nitrate is soluble. All nitrates are soluble. So if I take a nitrate is 1 minus. So the formula is going to be calcium nitrate twice, and I need to rub. I'll remove the charges. So my charges are now gone. So that's one of the soluble substance. The other soluble substance can be sodium phosphate. All group 1 salts are soluble. So sodium is 1 plus. So it's going to be Na3PO4. So the formula is going to be Na3PO4, and I'm going to remove these charges. So it's Na3PO4, which is going to end up, it's going to react with the calcium nitrate. Now, calcium phosphate will be produced when you mix two soluble substances. So both of them would be in solution form. One contains calcium ions and the other one should contain phosphate ion. Now I'm going to take a beaker. So I'm going to draw a beaker. And I'm going to mix sodium phosphate, which is Na3PO4, in aqueous form. So I'm going to mix Na3PO4 in aqueous solution form in this beaker, and I'm going to mix it and stir it with the calcium nitrate. Now remember, whenever your substances are in aqueous state, that means that it has ionized in water. So, and all the ions would be floating around. So sodium phosphate would be in ionized form. There would be sodium ions and phosphate ions freely floating around in water in aqueous state. And calcium nitrate would also, it's an ionic compound, it's going to ionize in aqueous state, producing calcium 2 plus ions and NO3 1 minus ions. So there would be plenty of sodium ions, phosphate ions, calcium ions and nitrate ions roaming around in this solution. And what's going to happen is that these ions are going to randomly combine with each other. So if sodium and nitrate ions combine, they're going to form sodium nitrate. So if sodium ions combine with nitrate ions, both of them in aqueous state, so they will end up forming sodium nitrate. But sodium nitrate is a very soluble substance, so it's going to, since it's a very soluble substance, so it's going to break down and ionize back again. So soluble substances if they combine, they're going to remain part of the solution in aqueous state. But what's going to happen if calcium ions and phosphate ions, they end up reacting together? So if calcium ions, they end up reacting or combining with the phosphate ions, remember a positive ion is going to attract a negative ion. So calcium ion was in aqueous state, phosphate ions were in aqueous state. Now when they combine and they form calcium phosphate, now calcium phosphate is insoluble, it's a solid, and it's not going to dissolve back into the solution. So this is not going to happen. So the solution, over a period of time, there would be less and less calcium and phosphate ions, and at the bottom there would be a precipitate formed. It would be a murky solution initially, and later the precipitate is going to settle down at the bottom. That precipitate would be of calcium phosphate, which is a solid. So your two products in your reaction, there would be two products. One would be calcium phosphate, which would be the insoluble substance at the bottom that can be filtered out, and the other product that remains in the solution is going to be sodium nitrate. As soon as sodium nitrate is formed, it's going to dissolve back into the solution, forming sodium ions and nitrate ions. So what we can write is that sodium nitrate would be in aqueous state, it would remain part of the solution, whereas the other product that is formed comes out of the solution. It forms a precipitate, and this precipitate can then be easily filtered out. So what I'm going to write in the exam is, if I'm asked to describe this process, the first thing that I'm going to write is I'm going to give an equation. So the equation that we've already mentioned is calcium nitrate. And remember, in chemistry, in papers in chemistry, equations are the best forms of answers. If you want to answer a question, give an equation if an equation applies to it. So calcium nitrate is going to react with sodium phosphate, and it's going to form an insoluble calcium phosphate, and sodium nitrate would remain part of the solution. So this would be in aqueous state. This is an insoluble salt that you're going to obtain. Sodium phosphate is also in aqueous state. Calcium nitrate is also in aqueous state. You need to balance this equation. So there would be 2 molecules of sodium phosphate, and there would be 6 molecules of sodium nitrate, and there would be 3 molecules of calcium nitrate. So that's your balanced equation. So that's the first point. You need to describe an equation. So what you're going to write down is that you're going to mix calcium nitrate aqueous in aqueous state with sodium phosphate, which is also going to be in aqueous state. Once you've mixed them, the second part is you will filter out the precipitate of Ca3PO42 formed. So you're going to filter this precipitate out, and once you have removed this calcium phosphate precipitate, because it's an insoluble precipitate, you're going to wash this with distilled water. So wash the residue. Residue is the term that is used when you filter things out. So you're going to wash this residue, wash the residue with distilled water. Remember to always use distilled water or mention distilled water. So wash the residue with distilled water. And once you have washed the residue, you're going to dry the residue between filter papers. Between filter papers, and there are many methods of drying. You can put the residue in the sun. You can put it and bake it in an oven. So the residue would be dried in that way. So that's how an insoluble salt, calcium phosphate, would be formed.